Imagine for a moment that when you open your eyes, you find yourself in an environment completely dominated by darkness, a place where there are no windows or doors, a space that seems to defy the very notion of orientation. Without any signposts, how can you tell whether you are on board a ship cutting through the vast cosmos at breathtaking speeds, or simply adrift in the vicinity of a colossal celestial body whose gravity embraces everything around it? What's more, as you try to explore this mysterious environment, you realize that the ceiling is so close that the idea of jumping becomes a distant dream. In this scenario, how would you begin to measure the time that has elapsed since the moment your consciousness emerged into this darkness? In this unusual situation, devoid of any conventional time-measuring tool, such as a clock or the alternation between day and night, you would be forced to resort to your most primitive creativity and instinct to mark the passage of time. Perhaps, in the absence of options, you would begin to count your breaths or try to establish a rhythm with your heartbeat, seeking some constancy in this sea of uncertainty. But what if sleep overcame you? When you woke up, how would you resume counting? Or even how would you be sure that time hadn't folded in on itself while you were resting? This scenario, although it sounds like something out of a science fiction novel, makes us reflect on the concept of time, this entity that is so present in our lives, but which, in extreme situations, proves to be complex. As human beings, we are used to measuring our days and nights, our appointments and leisure time, based on well-defined time systems and units. But when these systems are removed from our grasp, what remains is our intrinsic perception of time, something that, in this moment of total isolation and darkness, could be our only anchor to reality. This question may sound a little unusual at first glance, but it touches on something deeply familiar to all of us. You know those moments when, after a short nap, we think we've rested for just a few moments, but when we check the time, we discover that several hours have actually flown by? This strange sensation is more common than we think and leads us to an intriguing reflection. How would we, beings so used to measuring every second of our lives, deal with the perception of time in a scenario where traditional methods of measurement simply don't exist? We live in a world where everything is guided by schedules, agendas, and appointments, an existence meticulously orchestrated by the incessant ticking of the clock hands. But when we find ourselves stripped of these chronological restraints, we are forced to confront our intrinsic relationship with time, this continuous flow that, although intangible, shapes every aspect of our lives. By exploring this idea, perhaps we can discover that our connection with time goes far beyond the tools we use to measure it. Perhaps deep down, we have a natural ability to feel its passage, a skill that, with a little creativity and a lot of attention, can reveal new and surprising ways of interacting with the moments that make up our existence. So, how about reflecting on this? How do you think you would perceive time in an extreme situation where conventional methods of measurement are out of reach? We can talk about years, days, decades, hours, seconds, centuries, milliseconds, and even weeks. But what do all these units have in common? They are all linked to some form of oscillation that occurs in nature. For example, a year is the time it takes the Earth to complete one lap around the Sun, and a day is the period of one complete rotation of the Earth on itself. What about the second? It used to be defined as 1 day divided by 86,400, but today it is measured by around 9,122,631 770 cycles of radiation emitted by the transition between two levels of the cesium-133 atom. What does this mean? A day has 24 hours, each hour has 60 minutes, and each minute has 60 seconds. When we multiply 24 hours by 60 minutes by 60 seconds, we get 86,400 seconds. Therefore, the classic definition of a second was based on dividing the period of an Earth day by 86,400, representing the duration of a second as a fraction of the time it takes the Earth to complete a full rotation around its own axis. In physics, it was discovered that cesium-133 atoms emit radiation at an extremely stable and predictable frequency when they change from one energy level to another. This frequency is so constant that it can be used to measure time with unparalleled precision. Thus, a second has come to be defined as the time corresponding to the duration of exactly 9,631,770 of these radiation cycles. This definition allows for extremely precise time measurement, which is essential for advanced technologies such as GPS systems and telecommunications networks. Our understanding of time is based on finding regular oscillations in nature and using them as a reference. This leads us to think, what if we created our own unit of time? Imagine throwing a ball into the air and defining one light as the time it takes to go up and down. For different situations, different units of time would be more appropriate. It wouldn't make sense to measure the baking time of a loaf of bread in years, any more than we measure the age of the universe in seconds. The way we understand and experience time is profoundly influenced by the context in which we live. On Earth, our experience of time is dictated by well-defined natural rhythms. The planet's rotation on its own axis defines our days and nights, while its orbit around the sun marks the passing of the years. But have you ever thought about what it would be like if our existence took place in a completely different setting, such as another planet or even a different solar system? Imagine for a moment that the length of a day on another world wasn't 24 hours, but 40, 50, or maybe even 100 hours. How would that affect our perception of productivity, leisure, and rest? And it doesn't stop there. Consider the implications of a year that wasn't divided into 365 days, but perhaps into thousands of them, or conversely, into just a few days. The seasons as we know them would be completely redefined, as would our life cycles, celebrations, and rituals. Our units of time, meticulously adapted to terrestrial specificities, would become obsolete, forcing us to devise new ways of organizing our lives and activities. This exercise in imagination is not only fascinating, but also reveals how arbitrary and at the same time essential the concept of time is for the organization of human society. On a new planet, with different environmental and astronomical conditions, we would be challenged not only to reinvent our units of time measurement, but also to rethink fundamental concepts such as work, leisure, growth, and aging. In a world where the sun only sets every several Earth days, would our biological rhythm adjust to keep up with this new reality? How would we deal with the perception of aging on a planet where the years are significantly longer or shorter? These questions open up a range of possibilities for exploring how culture, society, and even human biology could adapt or evolve in the face of radically different temporal conditions.